Welcome back, grade 6. Today we are working on Nelson Math, chapter 14, section 4, communicating using diagrams. Today we're going to be looking at the diagrams that a student has drawn and seeing how we can better the communication and instructions about what the student did. So here we have a student named Khaled, and he's representing a box with a square here. So let's take a look at what he's done. I'll represent the box with a square. Then I'll show how to rotate the box to move it along the wall. And here's his diagram. There is nothing wrong with his diagram. His diagram is accurate. Our goal, though, will be to improve his explanation using measurements such as degree, center of rotation, and direction, like we have done in a previous section. To help his explanation, I'm going to label the point of rotation with an A. He rotated around this point, right there, where these two lines meet. That tells us that that's the point that stayed the same, the pivot point. So he rotated about point A. Now we can talk about the direction in which he rotated it. He rotated it starting from here, and he moved this way. That's counterclockwise. So by starting it here and then bringing it over here, that's counterclockwise. But now we want to measure how many degrees it is. This particular one is going to be very easy to measure because we know that on grid paper, all of the angles are exactly 90 degrees. So this line right here, which is the side of the box, this swung all the way up and has now become this line. That's a 90-degree angle, which we can verify if we bring this in, if we bring our protractor in, and we bring it right there. It's a 90-degree angle, which you could read off the protractor. In this case, we didn't really need the protractor. So this is where he brought it in its second position. In its second position, which is this box, you can see this is angle B. So right here, he's rotated it around angle B, and he still rotated it counterclockwise, and it's still a 90-degree rotation. So he rotated the box around angle B, counterclockwise, 90 degrees. Right here, I've labeled this angle, angle C. And once again, he's rotated it counterclockwise around angle C, 90 degrees. So we can say now that he rotated 3 times counterclockwise around these angles, each time by 90 degrees. His picture was very well done. What we did is we improved upon his explanation, putting very clear words to it using mathematical terms. And today, that's what you're doing. You're communicating using distance measurements, and you are communicating using angle measurements. Once again, for angle measurements, you need the point of rotation, the direction, as well as the number of degrees that it was rotated. But you're also going to be using other transformation terms. Thanks, everyone. Have a good day.